When a SaaS app breaks, users usually give you the benefit of the doubt. But when it lags, delays, or freezes, they do not complain. They quit. Most founders miss that. They obsess over bugs and ignore performance. And that's why their churn graphs look like a ski slope. What we're talking about today isn't just the speed for the sake of speed. We're talking about performance as a retention engine, a cost optimization tool, and yes, even a growth lever. If you find this kind of deep dive helpful, please subscribe to the channel. You will get weekly breakdowns on real SaaS product performance, architecture, and strategies that actually move the needle. Slack's engineering team once shared how even a small latency issue in their desktop app led to users opening the app less frequently. They observed a correlation between launch delay and message volume per user. And that's how deep performance cuts. Google found that a 100 millisecond delay in page load can reduce conversions by 1%. Not per second, per 100 milliseconds. Next thing's DEX report showed SaaS-related lags cause up to 12 lost workdays per user per year in B2B environments. So price of performance isn't in milliseconds. It's in churn, refunds, and support tickets. And yet most SaaS teams are blind to what is dragging them down. Let's start identifying where things really slow down. In 2017, LinkedIn migrated parts of their monolith to microservices. But before doing so, they profiled backend bottlenecks and discovered that over 80% of user-facing slowdowns were caused by unoptimized backend service calls, not the UI. That changed their entire roadmap. In over 250 SaaS products I have worked with, the top performance killers have rarely been React or Vue or CSS frameworks. The usual prospects: poorly optimized SQL queries, uncached API responses, overloaded backend processes, unmonitored scaling setups, and bloated, uncompressed frontends. Web analysis confirms this. 60% of SaaS latency issues stem from database and backend problems, not the front end. So instead of rewriting your UI, fix what actually matters. And the one place to begin fixing? Your database. When Shopify scaled its storefront engine, they invested heavily in query optimization, table partitioning, and caching layers. Their engineering blog describes how one analytics report that took over 10 seconds was brought down to under 200 milliseconds just by changing indexes and optimizing joins. Your database is where the majority of SaaS performance wins or losses happen. Here is what improves speed without scaling infrastructure. First, smart indexing. Smart indexing helps search efficiently, but too many indexes kill write speed. Use query analyzers like MySQL's Explain to see where queries are getting stuck. Second point, query refactoring. The number of select star queries we have found in production apps is mind-blowing. One client's report API was taking 18 seconds to load just because the nested subquery is returning 300,000 rows. A refactor dropped that to 700 milliseconds. Third point, connection pooling. Backend system making new DB connections for every request, that's a silent killer. Tools like PG Bouncer reduce CPU usage by 40% in one SaaS I advised. Point number 4, table partitioning. Especially helpful for logs, activities, and historical data. Partitioning by date or tenant ID reduces scan time and helps long-term maintenance. These fixes often reduces your AWS RDS bill without touching EC2. Once your database starts breathing easier, the next logical place to look is your API layer. At Netflix, the team discovered that high latencies in their personalized recommendation APIs were causing homepage tiles to load slower in regions with poor bandwidth. By introducing intelligent caching and edge logic, They improve the perceived performance and user engagement. Slow APIs are a domino problem. Lag one endpoint and everything else feels broken. So what works? Number one, Redis or Memcached caching. If your API responds with the same data for 5 minutes, cache it. You will reduce response time by 80 to 90% in many cases. Number two, paginate or stream. APIs returning entire tables are common in early stage SaaS, but it is inefficient. A such API we helped optimize went from 2.4 MB JSON data to a 120 KB paginated response with no user visible difference. Next point, compression. gzip and broadly should be turned on. It saves bandwidth, especially over slow mobile networks or in lower bandwidth geographies. Next, rate limiting. Your own dashboard shouldn't be allowed to spam your own APIs. Clients with no throttling have faced accidental DDoS by over-enthusiastic JavaScript loops. So guys, these are not tweaks. They are sanity preserves for your infrastructure. But good APIs still need to be delivered fast, no matter where your users are in the world. That's where front-end delivery and CDNs come in. GitHub's engineering team shared that introducing Fastly CDN reduced their asset delivery latency by over 50% for users in Asia Pacific. The same app felt snappier worldwide without rewriting a single line of front-end code. If your server is in Virginia and your customer is in Delhi, you are already 250 milliseconds behind before any JavaScript is paused. So here is what you should be doing. First, use a global CDN like Cloudflare, CloudFront, or Fastly. Next, serve JS or CSS bundles with long cache headers. Next, minify and bundle your assets. Your 5 MB React bundle needs to go. One startup we worked with shaved 1.4 seconds of their time to interactive just by pushing images to CDN and reducing third-party script calls on first paint. Now, once you are optimized delivery, the next step is to rethink how your backend resources scale with real-world demand. Coca-Cola's Europe division migrated some of their analytics and real-time campaign delivery systems to AWS Lambda. By using serverless computing, they scaled better during promotions, reduced idle compute cost, and improved SLA compliance during traffic bursts. We have had great results with SaaS clients who moved certain backend functions like image processing or email sending to serverless architecture. And why that works? First, you do not pay for idle time. Second, functions scale instantly. Third, you get isolations of workloads, no memory leaks affecting user requests. And add to that AI-powered auto-scaling from tools like Spot by NetApp or usage-based AI models in New Relic. And your infrastructure starts adapting before your users complain. We saved one client over $6,000 monthly simply by moving PDF generation from an always-on EC2 instance to AWS Lambda. Of course, none of this matters if you're flying blind, and that brings us to one of the most overlooked yet essential components: observability. Airbnb made one thing non-negotiable: visibility. From the start, they tracked every part of their system, so problems never caught them by surprise. Their engineering blog outlines how dashboard visibility allowed them to catch a memory leak that would have brought down their reservation system before Black Friday weekend. Without real-time metrics, they would have never seen it coming. You cannot fix performance without visibility. Yet, 80% early-stage SaaS teams have no proper monitoring in place. So here is what should be on your radar. First, backend response time. Second, front-end TTI, time to interactive. Third, database query duration. Fourth, error rates by endpoint. Fifth, memory and CPU usage by container or instance. Sixth, user satisfaction scores and reach click heat maps. To get this right, the right tools matter. And here is a simple breakdown by function. For backend monitoring, you can use New Relic to track API latency, memory leaks, and infrastructure performance. For user experience analytics, we use Mixpanel to understand user behavior, friction points, and impact of speed on engagement. Third, front-end auditioning. Use Lighthouse CI to automate performance checks on every build. Fourth, business impact visualization. Use speed curve to connect front-end metrics like LCP or CLS to business KPIs. These tools do not just show you numbers. They help connect engineering efforts with product outcomes, which is what performance work should always do. These are the maps your development teams needs to steer your product. But what does this all translate to in terms of actual business value? Let's see. Too often, teams treat performance fixes as a nice to have. But if you want faster UX to actually move the business needle, you need to make it a part of your product process. Why? Because speed directly impacts trial conversions, user retention, and infrastructure cost. So here is how you turn performance into a growth lever. Prioritize speed as a core product metric, not just a tech API. Set up regular performance audits, include backend, frontend, and API latency. Make TTI, which is time to interactive, and API responses benchmarks part of your release checklist. Make sure someone is clearly responsible for each part of your system's performance. Do not let it become everyone's and no one's job. Tie performance data to retention and conversion metrics inside your product analytics. This is how high-growth SaaS companies treat performance, not as an afterthought, but as a measurable lever in their product and business roadmap. So most performance problems do not need fancy architecture diagrams or full rewrites. They need curiosity, measurement, and small but intentional engineering decisions. If your SaaS feels slow, don't just ask what's broken. Ask what is wasteful, what is invisible, what is affordable, and fix that first. If you found this video useful, please subscribe. I share breakdowns like this on performance, architecture, and growth strategies grounded in real experience, not theory. This kind of stuff most SaaS founders and tech teams need to prioritize, because performance isn't about speed for the sake of it. It's about building better businesses. Thank you so much for watching.